आयनिक इक्विलिब्रियम का हम लोग बेसिक देखेंगे। बेसिक ऑफ आयनिक इक्विलिब्रियम, एसिड बेस कॉन्सेप्ट। और इसमें सबसे पहले आयनिक इक्विलिब्रियम, ऐसा इक्विलिब्रियम जिसमें आयंस का इन्वॉल्व हो। First of all, we will see the definition of electrolyte. Substances which dissociate into their ions on dissolving in water or melting is called electrolytes. Substances which dissociate into their ions on dissolving in water and or melting. Okay, we have some example of electrolytes like acid, bases and the salts. Type of electrolytes: strong electrolytes having the alpha is equal to 1 or in percentage 100%. Which means it dissociate 100%ly. For example, in strong electrolytes, acid, base and the salt. In weak electrolytes, by having the alpha less than 1, example acid and bases. Salt always in strong electrolyte. Okay, acid base theories. First of all, we will see the Arrhenius theory. Arrhenius told that acid are those which donate H plus or proteins in the aqueous solution. For example, HCl and HNO3, H2SO4, HClO4, etc. And the bases are those substances which donates OH minus in the aqueous solution. For example, NaOH, KOH and COH whole 2, etc. There are some example of strong acids. Look at this. Strong acid: HClO4, HClO3, HBr, HI, HCl, HNO3, H2SO4. That is called big 7. I have to remember this: HClO4, HClO3, HBr, HI, HCl, HNO3, H2SO4. There are some weak acid like HCN, CH3COH, H2S, H3PO2, H3PO3, H3PO4 and H3BO3. CH3COH and H2S and HCN already in mind, but there are some little confusion when the words come with H3PO2, H3PO3, H3PO4 and the H3BO3. Okay, look at some strong bases: LiOH, NaOH, KOH. Group 1 bases in the periodic table, and the group 2 bases SROH whole 2, BaOH whole 2. And the strong bases generally in mind, but in weak bases we are sorely confused, like BeOH2 and the MgOH2, CaOH2. Organic bases like CH3NH2, C6H5NH2, etc. And these organic bases are non-Arrhenius bases because these have no OH. Then how we can say that CH3NH2 is the basic? But by the concept of different scientists, it is basics and it is also basic. NH4OH is also a Arrhenius base, we can say. CH3COH aqueous dissociate into CH3CO minus and the H plus in the ions. Now look at about the Bronsted and the Lowry theory. Bronsted-Lowry theory. Bronsted told that acids are those substances which donate H plus and the bases are those which accept H plus. Like this is an example in which HCl plus NH3 and in the Cl minus and NH4 plus. In this HCl donates H plus, that's why it is called acid, and the NH3 plus accept H plus, that's why it is called Bronsted base. Okay, and look at this. Now we will study about the conjugate acid base pairs. Okay, look at this. Conjugate acid base pair. In these species which differ by only one hydrogen are called conjugative acid base pair. If we will look about this, HCl and Cl minus, there is only a difference of one H plus, that's why it is called conjugated acid base pairs. Okay, look at some examples below. Now HCl and Cl minus, HCl and Cl minus are the conjugative acid base pair because there is a difference of one H plus. HCOH and HCO minus is the conjugative acid base pair because there is also a difference of one H plus. NH3 plus or NH4 plus is also a conjugate base pair because there is also a one difference of H plus. And the NOH and the Na plus is not a conjugative acid base pair because there is a difference of not H plus, there is a difference of OH minus, that's why this is not a conjugative acid base pair. H2S and HS minus, this is also we can say the conjugate acid base pair. Okay, look at this CH3COH and the CH3COH2, there is difference of one H plus, that's why it is called conjugate acid base pair. There is H2S and H2 minus, there is a difference of 2 H plus, that's why this is not an conjugative acid base pair. Okay, look at this CH3COH and the CH3COH2, this is called conjugative acid and this is conjugative base. Conjugative acid has one proton more. Look at this, in both species, in this species one proton is more, that's why this is called conjugative acid, and in this species CH3COH one H plus is less than as compared to the this species. Okay, we can remember this, conjugate acid has one proton more and the conjugate base has one proton less. To find the conjugative acid of the base, add one H plus. If we want to find conjugative acid of base, then add H plus. And if similarly, to find the conjugate bases, remove H plus. To find conjugative acid, add H plus. And if we want to find conjugative bases or conjugative acid, then remove H plus. And if we want to conjugative acid के लिए we will add one H plus, and to find the conjugate base of acid we will remove H plus. Okay, there are some example we will study. Now this is the example. Find the conjugative acid of OH. If we want to find the conjugative acid of base, then we will add one H plus, then it becomes water. Then this is example. Now there is some question. Find the conjugate base of HCO3 minus. Okay, we will find the conjugate base of this acid, then we can remove one H plus, then we got CO3 2 minus, and which is the conjugate base of SCO3. That is the example's answer. Okay, now find the conjugate acid of ZnOH whole 2, ZnOH whole 2 plus H plus, conjugate base acid of ZnOH whole 2. As we know that ZnOH is in the form of like this, and if we want to find conjugate acid, then we will add a one H plus, and this becomes like this, and after that water gets out and form ZnOH plus, which is the conjugative acid of ZnOH2. Now conjugative base of a strong acid is a weak, and vice versa. Okay, conjugative base of a strong acid is weak and the vice versa. HCl strong acid dissociate into H plus and the Cl minus, and look at this strong acid, and this is the weak base, more stable. There are some trick to find the strength of acid and bases are related. Okay, first of all, first trick, when the reactant are of the same nature. When the reactant are of the same nature means if the reactant, one reactant is acid, then other reactant also should be acid. Like this, CH3COH is acid and the HCl is acid, then we will not think anything and put that HCl is weak acid and the CH3COH is the weak base, and similarly weak acid, and this is the strong base and the strong acid. Okay, and when the reactants are of the opposite in nature, like that CH3COH is acid and NH3 is the base, then we will not think anything and will put at that a strong acid and the strong base, and similarly in the product side we will put the weak base and the weak acid. In the with the water जो जैसा हो वैसा, like HCl is strong acid plus H2O, that is strong base, then H3O plus weak acid and Cl minus is the weak base. Okay, if we add strong acid, then water will be have like a strong base. If we add weak base in the water, then water will be have as a weak acid. Water we have according to the reactant. Okay, look at this question. Which is the conjugate base of a strong acid in the given reaction? H2SO4, which is weak acid, and HCl is the weak base. Okay, H2SO4 weak acid है, मतलब देखो both are of the same type, then we will not think anything and put at the weak acid and the weak base. Simultaneously in the product side, weak acid conjugate strong base and the weak base conjugate strong acid. Okay, Le Chatelier principle. Look at about the common ion effect. On mixing a strong electrolyte with the common ion as a weak electrolyte, it suppresses the dissociation of weak electrolyte, and this is called the common ion effect. Okay, if we add CH3COH then CH3COO minus or H plus, and if we add any strong electrolyte like HCl and it dissociate into H plus and the Cl minus, then the concentration of H plus in the solution increases as per the Le Chatelier. According to the Le Chatelier, if the concentration of product side is increases, then the equilibrium shift towards the backward. That's why the equilibrium shift towards the backside and the suppresses the weak electrolyte, suppresses the dissociation of weak electrolyte. This is called the common ion effect. Now odd ion effect, in as similarly, if we like CH3COH dissociate CH3COO minus and H plus, then we will add NaOH, a strong electrolyte having the odd ion, like it dissociate in Na plus and the OH minus, but H plus and the OS minus combine together and form water, and the product in the product side the concentration of H plus decreases. According to the Le Chatelier, equilibrium shift towards the product side because the concentration of the product is decreasing. That's why this is the odd ion effect. Due to odd ion effect, dissociation of weak electrolyte has increased. So as with the product concentration decrease, the dissociation of the reactant is increased and the equilibrium shift towards the forward. Okay, look at this log. Okay, remember about log and its properties. First of all, remember the value of log 1 is equal to 0, and the log 2 value is 0.3, and the log 3 value is 0.477. okay, up to 2 digit enough, and log 4 is 0.60, and the log 5 is 0.69, and the log 6 is 0.7, and the log 7 is 0.85, and the log 8 is 0.9, and the log 9 is 0.95, and the log 10 is equal to 1. okay, there is some calculation like xa plus b, we can write xa dot xb. okay, log 9000, we can find the log 9 into 10 to the power 8, and log 9 plus 10 to the power 8, then value of log 9 is 0.95 and plus 8 into 10, 8.95. Calculation of anti-log. Log x is equal to y, so x is equal to 10 to the power y, log x is equal to 4.5. okay, remember the value of 10 to the power 0.5 is equal to 3.2, and the 10 to the power 0.25 is equal to 1.7, and 10 to the power 0.3 is equal to 2. 10 to the power 0.5 is equal to 3.2, and 10 to the power 0.25 is equal to 1.7, and 10 to the power 0.3 is equal to 2. okay, x is equal to log x is equal to y, x is equal to 10 to the power y, anti-log. okay, if we have example, if log x is equal to 4.5, then x is equal to 10 to the power 4.5, then we will write x is equal to 10 to the power 0.5 plus 0.5 plus 4, okay, is equal to 10 to the power 4 into 10 to the power 0.5, and as we know that 10 to the power 0.5 is 3.2 into 10 to the power 4 is the value. okay, look at this. If we have to find the value of log x is equal to, the x is equal to 10 to the power minus 3.7, then we will write this 10 to the power 0.3 into 10 to the power minus 4 is equal to 10 to the power 0.3 the value 2, and the 10 to the power 0.4. okay.